If you've spent enough time working in Blender, you've no doubt learned how to set up a material for PBR, or physically based rendering. There are countless tutorials out there on the subject, but here's a quick rundown. You have an albedo texture, roughness and normal maps, maybe a metal or emissive map, or perhaps even a height map. I did a whole video on that. Plug them all into a printable BSDF, add an HDRI to your scene, and boom, you've got a realistic material. Except there's that one other map we forgot about, ambient occlusion. Just what exactly is that for anyways? Well, you know how even in a fully lit room you can still see soft shadows in the corners of the walls and such? That's ambient occlusion, as in the occlusion of ambient light. It's a subtle effect that goes a long way towards making our renders look that much more convincing. Even most game engine shaders support it right out of the box. Sadly, Blender does not, at least not anymore. It has an ambient occlusion setting in the render panel, but that's only for geometry. How do we use ambient occlusion in our materials? Simple. Add a mixed color node to the albedo, plug the AO map into the second slot, and set the blend mode to multiply. See? Easy. Except that's not how ambient occlusion works. That's right, every tutorial out there about using AO maps in Blender is wrong. All wrong! Every last one of them! See, ambient occlusion is supposed to be the occlusion of ambient light. It should only ever be visible under ambient lighting, apart from all other light sources. Yet using it like this makes it visible under all lighting conditions, even under an ultra-bright spotlight. You might as well just merge the AO map into the albedo in Photoshop and save yourself the extra draw call. So if everybody's just been wrong this whole time, how do we actually use the AO map? Well, ironically enough, we use a tool most commonly used for non-realistic materials. See, Eevee is more performant for rendering than Cycles because it's raster-based rather than path-traced. A lot of the detail is being faked like in most game engines, with many of the same limitations. However, it does have one thing that Cycles does not: shader to RGB. Most people will tell you that shader to RGB is for creating toon shaders, and while that is what it's primarily used for, that's not all it does. In basic terms, shader to RGB converts shader and lighting information into usable data. That's why it's so useful for NPR, or non-photorealistic rendering, as it allows you to completely customize the way a shader looks. In our case, however, we're going to use it to control the appearance of a pre-baked ambient occlusion map in Eevee. First, add a mixed color node to the albedo, plug the AO map into the second slot, and set the blend mode to multiply. Wait a minute, didn't we already do this? Yes, but now we add the control. Add a shader to RGB node and plug a diffuse BSDF shader into it. This will expose the color data from the diffuse shader, which we can then control by plugging the color into a color ramp node and plugging its color into the factor of our previous mix color. Things are looking a little backwards, so we'll just reverse the ramp's color stops. Ta-da! A working ambient occlusion map. We can even move the stops around to fine-tune the fall-off to our liking, add a brightness contrast node to the map to make it more pronounced, or switch the ramp to constant for a more toony look, which we can naturally do to everything else. You can even use this technique to do other cool stuff, like lights that only turn on in the dark. Use it to make planets with lit cities. But wait, what about Cycles? Well, Cycles doesn't typically use AO or AO maps, since much of that is basically automatic as a result of path-traced rendering. However, we do have access to an AO pass for our view layers, so how do we make use of that? Here's a quick bonus tutorial on how to properly composite ambient occlusion in Cycles, if you want it. First, go to the View Layer Properties panel and under Light, enable the ambient occlusion pass. Go ahead and also enable Environment for good measure. Now create a new view layer. I'm calling mine Solid Render. This will be for capturing light fall-off on all our geometry. With this new layer selected, at the bottom of the Properties panel under Override, assign a blank white diffuse material to the Material Override slot. This will replace every material in the scene with the override when we render the layer. Next, in the compositor, add a Render Layers input node and set it to your Solid Render layer. You'll notice the outputs on each layer is different based on their enabled render passes. Add a Mix node, plug your main layer's image output into color slot 1, plug the AO output into slot 2, and set the blend mode to multiply. If you want things to look a little prettier, go ahead and add a denoise node to each output and a gamma node set to 10, or whatever you want, to the AO to help darken it. Plug the solid render layer's image output into a hue saturation value node and set the saturation to 0 to make it grayscale. Plug that into an invert color node, set the factor to 1, and plug that into the factor of our multiply node. To separate the background for a bit more control, add another mix node set to mix, plug our multiply node into slot B, our main layer's environment output into slot A, and its alpha output into the factor, plugging the final result into our composite node. Oh, and don't forget to check transparent under film in the render properties panel. Hit render, wait for it to finish, and there we go. Composited AO in Cycles. So there, I've finally settled the score on how to properly use ambient occlusion in Blender. Shout out to Retmia and Person132 for making the Blender Stack Exchange posts that inspired this whole thing. Hopefully now we can actually start making our stuff look good instead of parroting the same bad information for clicks again and 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 again.